Hi, this is Aditya from Just Tutors, and in this video we are going to learn about electric current and its effects. Now in today's video we've got four subtopics. We will start with learning about electric components first, then we will move on to the heating effects of electric current. We will also learn about the magnetic effects of electric current, and at the end we'll conclude with learning about electromagnets. So let's start at the first topic, which is electric components. Now, an electric component is any device that is used to affect the flow of electrons in the electronic system. Now, these components have two or more electrical terminals. These terminals connect to create an electronic circuit with a particular function. As you can see, one of the examples of the electric components is this battery, which is made up of so many electric cells. One such example is this electric bulb as well. You can see the two terminals right here. Now these electric components have a few symbols associated with them. This table right here shows the different symbols for the different electric components. So the first symbol here is of the electric cell. This is shown by one positive and one negative terminal. Now a battery is made up of so many electric cells, so that's why it has got this symbol. This one is for the electric bulb. This one shows the switch in on position, and this one is in the off position. For wire, we just use a straight line like this. So now we'll move on to the heating effects of electric current. So whenever an electric current flows through a wire, the temperature of the wire gets up, or we can say that the wire gets heated up. This is known as the heating effect of electric current. Some example of these appliances which work on this principle are electric room heater. It can be the electric iron as well. As you can see, they have got this wire inside them. When current flows through them, they get heat up and provide warmth to the surrounding. Some more example of appliances that work on this principle are a hair dryer, an electric stove, an immersion water rod, coffee maker, etc. Now we'll learn about how the appliances work on the principle of heating effect of electric current. Now these appliances have coils made up of wire, which are known as the heating elements. If we talk about a bulb, the filament right here is the heating element. Now these elements are known to produce heat when electric current flows through them. When we talk about a heater, the wires provide heat to the surrounding. But when we talk about an electric bulb, they also provide light to the surrounding. As the current flows through the filament of the bulb, the heating element turns into bright orange-red color. This is because a huge amount of heat is produced, and the filament of an electric bulb gets heated to such a high temperature that it starts glowing. Next up on the list is electric fuse. Now this is used as a safety device in our homes, and it's used to prevent damages to an electric circuit when excess current flows through it. The electric fuse works on the principle of heating effect of electric current. It consists of only a piece of wire which is made up of a metal or an alloy which has low melting point. Now the reason it has low melting point is because so that when the current flows and the temperature increases, the electric fuse melts first, thus providing a break in the electric connection. This phenomena is termed as the blown off state. As the current increases beyond a limit, the circuit is broken and the current stops flowing through it. Thus, a fuse prevents fire. Now we'll talk about the magnetic effects of electric current. Now, when an electric current flows through a wire, the wire also starts behaving like a magnet. This happens because a magnetic field is created around a current carrying wire in a circuit, due to which the wire starts behaving like a magnet. This phenomena is termed as the magnetic effect of electric current. Now, this phenomena was discovered first by Hans Christian Ørsted. Now, we use the magnetic effect of electric current in various devices like the electric motor and the loudspeakers as well. The final and foremost topic is electromagnet. An electromagnet is formed due to the magnetic effect of electric current. When electric current flows through a wire which is wound around an iron bar, for example this iron nail right here, and as you can see there is a coil of wire which is wound around this iron nail, and this coil is connected to the two ends, or you can say the two terminals of this battery. Now when current flows through these wires, the iron nail turns into a magnet. Now these kinds of magnets are also called as electromagnets, as they are a result of the electric current which flows through them. Now these electromagnets have a wide application. They are used in toys, iron industries, electric bells, cranes, etc. One such electromagnet is used in an electric bell. Now we'll discuss about the circuit of an electric bell. It consists of an iron core on which a wire is wound as a coil. You can see them right here. It also has a battery, and the coil is connected to the two terminals of the battery. There is also a steel rod that acts like a spring for the hammer that hits the bell. And at the end we've got a screw contact which is with a switch in the middle. When the switch is on, electric current flows through the coil and the iron core acts as an electromagnet. The iron core attracts the hammer towards it. When the hammer hits the bell, it produces a sound. That's how an electric bell works. Now it's time for some practice, so pause the video and attempt these questions. The answers to the question are provided here. Pause the video again and attempt these questions. Check your answers again. That's all. Thanks for watching. For more, please visit justtutors.com.